Oh, yes, it's good to be back. Indeed, indeed it is. And welcome to Nothing Like a Good Book. It's another show, and it's all about authors, dedicated to authors, in fact, whether you've written one book, thinking about a book, whether you've written a hardcover, a novel, paperback, Kindle, anything, e-commerce, doesn't matter. You're a writer, and that's what counts. And this show's for you. And we're going to be talking with somebody special today. Nothing Like a Good Book. The site is just about to open. It's all about discovering you and your book, promoting your book, and as it says there, selling your book. Getting them out of the garage. That's a standard joke. All right, so you can visit the, construction page at the moment, nothinglikeagoodbook.com. But it'll be opening soon. Now, tonight, the afternoon, whenever you're watching this, wherever you are, Norman Stewart is his name, Norman Stewart. And he's written a book called Freed from the Iron Grip of Frost. Very relevant book, this, I'll tell you now. The book Freed from the Iron Grip of Frost explains the physics of the greenhouse effect and reflects his continued interest in meteorology. He's followed the topic of global warming closely for many, many years. And when he looked for books on the subject, he was quite surprised. He couldn't find anything. Actually, very, very little. So what did he do? He wrote his own, of course. So I'd like to welcome Norman Stewart. Hi, Norman.
Hello, Mark. Thank you.
You're most welcome. You're in Ireland and you're in Dublin.
Yes, I'm in Dublin at the moment. Yes.
Very good.
I wish we had some of your weather.
Yeah, nice weather, not raining.
Not at the moment. Give it 10 minutes.
I had the pleasure of visiting your beautiful country last year.
Okay.
And where did we land? We went in Shannon and then north to Galway, then down to the Ring of Kerry.
Oh, lovely.
In Killarney. Killarney or Killarney?
Killarney. Yeah.
Killarney. And then to Carsavine. And then to Tipperary and Kilkenny, then back up to Dublin.
Ah, lovely.
Lovely trip, beautiful people, and the roads. I love the roads. They reminded me of the bush roads out in outback Australia.
Nostalgia.
The car, of course, she's on the left, the same as Australian driving.
Same as Australia, yeah.
All the hedges sticking out, and some of those houses are right on the side of the road. Everything's good till the tour bus comes at you on the skinny road, and then when you get around that one, then you've got a tractor to worry about. Welcome to Ireland. Beautiful place. Highly recommended to anybody. The book. Oh, that's why we're here, the book. Now, it aims to explain the physics of the greenhouse effect, right? To the non-specialist like me, in a reasonably digestible form. We'll have the book up soon. And you have taken a historical approach with the development of the subject from about 1800 onwards. Correct?
Absolutely correct. Yep.
Okay. Your book aims to explain the physics of the greenhouse effect to the non-specialist. Today, it's a hot topic, right? Everywhere we're looking, there's more floods, more this, hotter, this and that. I mean, you can't deny now, can you really, about global warming?
Well, my angle, Mark, is to explain the physics. There's plenty of talk about the impact and the politics and policy, et cetera, et cetera. For me, what was missing was the underlying physics. I find that the vast majority of people really have a very poor idea of what's actually happening, under the hood. They see a lot of stuff in the media and they see technical terms and they don't really understand them. So what I was looking for a few years ago was a book that explains all this. And when I found that there wasn't anything out there, I said, I'll do it myself. So what I'm trying to do is to give the man in the street with a little bit of scientific knowledge. It's not for everybody, but I say for somebody with high school science,
well, there's a lot of readers that would dig that, quite frankly.
Exactly. Yeah.
It is organized around personalities, Norman, with a chapter dedicated to each of the major scientists who contributed to progress in the field,
Yeah.
human aspect to it as well as the scientific, but the main focus, it is on the physics, isn't it?
Exactly. Yeah. Because I was trying to aim it at the general reader, the non-specialist, I tried to find a format that was a bit approachable with human beings, little anecdotes about people's lives to make it a bit more palatable for the non-specialist. So I decided to structure it by people. So there's a chapter on each of the major contributors. I don't cover everybody, but the major contributors in the field going back to the year 1800. That was just
a lot of history. That's a lot of history.
It took a lot of reading, I tell you, including in French. The original sources going back to 1800 are in French. So that was to try to make it palatable, a little bit of soap opera, not just. It's not a textbook. I'm trying to make it an approachable book.
Well, that's a good idea. I think books are a beautiful gift. The art of reading has got to come back. Somehow we've got to bring the youth back, even if they do read it on a down phone. You know what I mean? You come from Dublin in Ireland, where you are right now as we record this show. You were born there, grew up there?
Yes.
And while in Dublin, you studied physics at Trinity College.
That's correct.
While you were there, a famous physicist visited Professor Ernest Walton. He was a Nobel Prize winner, one of the atom splitters, yes?
That's right. He was actually at our university. He was the professor of physics at that time.
Right. So let me get this right. It was the duo, right? And you read this in the book. It was the duo of Cockcroft and Walton, right? When they were at Cambridge University in England, they were the first to artificially disintegrate an atomic nucleus.
That's correct.
That's correct?
Yes, that's correct. And they got the Nobel Prize for that. And Walton subsequently came back to Trinity College Dublin, and he was still there in my time.
Well, in fact, they were famous atom splitters, and they won the Nobel Prize, as you say, in physics for that. So what effect, let me ask you this then, what effect did this have on you back then?
Well, it was lovely to know Walton, to meet him, to talk to him, to see what a Nobel Prize winner looks like in the flesh. He was a great inspiration to study physics and to appreciate physics, and the link to people like Rutherford was really nice.
Right.
But at that time, what got me interested in the climate issue was the fact that at that time, the first computer models were coming out. In the late 60s, early 70s, people like Manabe in the US were using digital computers to do computations, modeling of climate effects due to CO2. That was being reported in the scientific magazines like New Scientist at the time. And we as undergraduates, we thought, oh, this is interesting. So we kind of followed it. There were updates every now and again, and that's really where my interest started. So that's over 50 years ago.
Oh, that was just like yesterday,
Yeah.
So what happened? What happened then after studying physics in Trinity College in Dublin?
Well, I went to Canada. I did a master's in theoretical physics. And then I came back to Edinburgh in Scotland to do a PhD in astrophysics. In astrophysics, part of my work involved the atmospheres of stars, stellar atmospheres. So that gave me a bit more insight into atmospheres and the physics of atmospheres and the relevant equations that apply and so on. Atmospheres and stellar atmospheres and planetary atmospheres, they're kind of similar from a physicist's point of view.
I wonder. I'm sorry.
Sorry, Mark. Sorry to interrupt. So after that, after my PhD, I went to work at the UK Met Office, and I became a meteorologist. So I trained as a meteorologist at the UK Met Office, and that gave me a much deeper understanding of specifically the Earth's atmosphere, the applicable physics, and things like how we do numerical computation on the meteorology, the Earth's atmosphere, numerical weather prediction, which is all related to the climate issue and how we tackle it.
Right. There's a lot of stuff in there. I mean, you're a brainy fella. You know, most people wouldn't take this on in a lot of ways. A lot of study in there. How did you find time to do that? That's what I want to know. Master's degree in theoretical physics, McMaster University in Hamilton, Ontario. After that, I went to Edinburgh in Scotland, and I did a PhD in astrophysics because I got bored, I guess. My PhD was on the evolution of galaxies. Aha! Using evidence provided by star clusters. They called globular clusters, right?
Globular clusters, yeah. And that brought me to Australia, of all places.
Oh, really? Where did you go?
The Siding Spring Observatory in New South Wales.
Beautiful other parks.
Not far away, yes. Top of a mountain. That was great. That was 1978.
Well, men were men and women loved them for it. Oh, yeah, beautiful Australia. Well, we're there with the stars and all of that because of, the astronauts and so on. We're even on the landing on the moon, we were a critical link.
Okay.
The galaxies, you talk about, so you finished your studies in 79. Then you went to work at the Meteorological Office of the United Kingdom, which is based near London. So while you were there, you trained as a meteorologist.
Exactly.
Is that easy for you?
Well, nothing's easy, but it was doable. I had the theoretical physics. I had the underlying physics. It was doable.
A master's in theoretical physics, PhD in astrophysics, and then fully trained as a meteorologist. All right, let's talk about your book, Freed from the Iron Grip of Frost. Might do a little later there, I think.
Will I explain the title, Mark?
My word, I was an hour into this because I wanted to get your background of somebody who's so qualified in what you do, what you've done, what you understand. Because there's so many people get up and, rave on about, the weather, global thingamajig, global this, global that, they don't know what they're talking about. Heads of states, presidents, prime ministers, it's all crap. You know what I mean? Well, it ain't. And you explain, so a dummy like I can read a book like this and say, that makes a lot of sense. Now I can understand what the devil's happening. Because you and I won't be around in 30 years. Well, what's it going to be like in 50? So anyway, this is the book. Please explain, if you'd be so kind.
Yeah, there was an Irishman called John Tyndall. There's a chapter on him in the book. We'll come on in a bit more detail later to his work, but he raised the term iron grip of frost. What he said was, in wonderful prose in about 1860, he said that without the greenhouse effect, England would be held in the iron grip of frost. In other words, it would be so cold, life would be impossible. So what he was doing was explaining how important the greenhouse effect is in keeping the Earth habitable. So it's a lovely phrase. So the greenhouse effect frees us from the iron grip of frost. Right.
And you'll notice on the screen too, folks, that the old Lorem Ipsum Lala, this was just the original before it was all written. Of course, it's done on the book.
Yes. Yeah.
But, this was the only JPEG we had to be able to at least show the cover in reference to what it was.
It does the job.
It's a nice shot. I like that. That's above the earth.
It's a fabulous picture. Yeah.
I can't take the cold, buddy. I'll tell you now. That's why I'm in Arizona. Initially, you did research work on meteorology of rainfall statistics of rainfall distribution. But most of your time at the Met Office, you spent working on the development of meteorological instrumentation, right?
Correct.
It had a specialist unit devoted to development and new observing instruments, techniques at that time. Microprocessors were developing very rapidly, and applications were being found in automation of meteorological measurements. So you spent a lot of time developing electronic systems and software from that point. So in that day, you didn't have stuff then compared to today that they can do the weather with, right? And what they can find out about, what the meteorologists can do.
It was the early days, Mark. We had numerical weather prediction in a very primitive form compared to today. We had very, very early meteorological satellites, again, very primitive compared to today. We were just starting automation of meteorological measurements using intelligent sensors, using microprocessors and so on. It was the pioneering days of a lot of these technological developments.
Right. Pioneering days. Look where it's got today. You went back to Ireland after all of that, back in, I think, 1995.
Yes.
Ago, doesn't it?
I spent 10 years in the UK and then another 10 years in Germany.
So why back to Ireland? What did you do this time?
Oh, that was a family issue, really. It was a minor crisis that led me to come back to Ireland in the family.
Okay. I think but didn't you do something with software companies as well?
Yes. When I came back to Ireland, I was involved in setting up two companies, one that in the meteorological field, distributing meteorological data. That was a company called Nowcasting International. And then the other company was in the aviation sector, a company called Airtel, based here in Dublin.
So what can you tell us? What is happening now? Without giving the book away, but what's the focus in the book that you want to get across? If anything else, what's the biggest takeaway that you'd be happy that the readers would get?
It's the kernel is the mechanism by which increasing CO2 concentration leads to warming. That's the key issue. When, as you mentioned, lots of politicians talking about stuff, they don't really understand it. They talk about blocking radiation, blocking the heat coming from the earth, and so on. But it's very, very subtle. It's much more complex than is explained in the media. There are some very subtle effects going on, and it's important to understand that because it gives you an idea of the extent of the issue, just what's going on, and quantitatively what it means.
Well, there's a couple of things that are thrown at us, of course, through the media today. One of them is, of course, that the sun, is heating up from a point of view of it's getting hotter on Earth. Well, because of our, the zone and all the soot going up and all the crap into the air, it puts this ring around us that makes it very difficult. It gets too hot for the ice caps and ice. It starts to melt. The seas get bigger and we're getting more and more flooding. And from what I can understand, there's parts of America and other island countries, for that matter, that are starting to get a lot of water coming in. But where does it go from there? What happens after that? I mean, is that what's really causing it?
Well, the book is more focused than that, Mark. The book is really looking at what's happening physically. What's the physics of this effect? We've been looking since the 19th century, asking the question, as we through industry and various other human activities, as we put more carbon dioxide and other gases into the atmosphere, what effect does that have specifically on the average temperature of the Earth, on the radiation from the Earth into space? That's really what the greenhouse effect and the enhanced greenhouse effect, i.e. the human-caused greenhouse effect, what effect does that have on our the temperature distribution on the Earth, and through that on our climate? That's very specifically what the book addresses. It's really the essence of the question, and has been since the 19th century. So what I try to address is the question of what's the mechanism in detail by which increased carbon dioxide concentration affects the radiation from the surface of the Earth out to space. Is that an increasing effect or a decreasing effect? How much? These are the real issues. So we had in the 19th century people who just in the early days speculated about what it might be. Towards the end of the 19th century, we had a guy called Arrhenius who tried to do some computations on it using measurement data. And gradually then in the 20th century, as we developed digital computers and satellite imaging, we tried to focus in more and more on a reasonably accurate computation of what's going on. But the key issue is radiation and the interaction between radiation and the molecules in the atmosphere. Okay. So the sun warms the Earth. The visible light from the sun passes through the atmosphere, most of it. That warms the Earth. But the warmed Earth then radiates infrared. It tries to radiate away infrared into space. But it turns out the molecules in the atmosphere interact with that radiation and prevent it from getting out to space completely. It partially blocks the radiation from the Earth. Right. So the Earth is at an average.
So where does all this radiation go?
Some of it goes straight out to space.
It gets through. It gets through the atmosphere.
Exactly. It depends on the wavelength. For some wavelengths of infrared coming from the surface of the Earth, it just goes straight out to space. Doesn't interact with the molecules in the atmosphere at all. For other wavelengths, it gets scattered, blocked by maybe water vapor. Water vapor has the biggest effect, depending on the wavelength. For other wavelengths, it'll get blocked by a carbon dioxide molecule, some by methane, some by nitrous oxide. So depending on the wavelength, it either gets through or it doesn't, or it gets scattered back to the surface of the Earth. So it's a very, very complex scenario with lots of different molecules acting at different wavelengths. So you have to look at each wavelength in the infrared from Earth, because they're all different depending on what molecules they interact with. Some there's no interaction, some there's more. So you have to look right across the infrared spectrum. You have to look at the activity of each molecular species that exists in the atmosphere. Hugely complex computation. So, you
know what, Norman? I wish you were my science teacher when I was at college. I would have learned a hell of a lot more. That's amazing. And it's all in the book and it gets deep and all the rest of it. Okay. Give me the bottom line. Where are we going?
I'm trying to keep focus, Mark, on the physics. There's plenty of people making forecasts about what will happen in the future, and all I can do is refer you to the IPCC, the Intergovernmental Panel on.
But you'd have thoughts, you'd have opinions. Let's say I was the president and I called you in and I said, "Look, I just want an honest assessment on what you think the weather's going to be in the next 5-10 years to us if we don't do something, right? And if you think we're going to be okay, then tell me that. Whatever. You don't have to scare people, but you know the nitty gritty of what's going on."
I don't think anybody really does, Mark. To be honest, I really don't want to take a position in public on that. We're getting into politics there and public policy.
All right.
For me, what I'm saying is the deficit is in the science, in the physics, in the public domain. We need to improve public understanding of the physics of this problem. That's where the deficit is. We've plenty of people talking about the models and the impacts and the rising sea level. That's covered. What's missing for me is the science. We need to explain the science to the man in the street.
All right. That's a heck of a challenge, isn't it? How do we do that?
It is. It's an enormous challenge. Yeah.
Did you get invited to speak or to talk at all and travel?
Not on this subject.
You should.
No. Maybe the book will trigger.
Hopefully for you. That'd be fun.
To be honest, until recently, I've been so busy with my business, it would have been very difficult.
I have to say, Norman, you've lived an incredible working career, and that's not over yet. I can see that. Why this book now?
The trigger was accidental. It was COVID. I was during COVID. We were in lockdown. I mentioned I was looking for books, couldn't find one, so I thought, well, we're in lockdown. What else am I going to do? I'll write the book. So it was the opportunity came during COVID during lockdown to write it.
Right. Well, you're permanently up on my site on markbishopmedia.com until I can get the other side going, and then all the books and authors will be over there then, and their covers and so on featured. For the moment, you'll be up with your bio and all about you. Email is there for people to contact you. The book itself can be bought where?
Amazon and Kindle.
Who? Amazon. Never heard.
Amazon.
Oh my God! Thank God for Amazon and that. Barnes and Noble.
We're working on that.
Good one. Okay. Any others you want to mention?
Now, just on the formats, it's available on Kindle as an ebook. It's available as hardback and paperback from Amazon.
Well, you're easy to listen to. I think that'd be. What about an audiobook?
We've talked about that, Mark. The problem with that is it's a very visual book. It's full of illustrations.
Right,
and they would be lost in an audio book.
Interesting. So it's all very well thinking about an audio book as an author, but you've really got to consider what the content is about.
Yep.
And certain things work and certain things don't. You're on LinkedIn.
I have 50 odd figures and a dozen tables in the book, and that would all get lost in an audio book.
Yes, it would. It's very, very visual indeed. And so it's Amazon. You can look her up. But Freed from the Iron Grip of Frost. I mean, can you imagine the world covered in frost? Right?
That's what it was like. Well, not the whole world, but where I am in Dublin, it was covered in ice 12,000 years ago.
Fair income.
Our country is still recovering from the melting of the ice. Yep.
Very interesting.
Hydrostatic isostatic rebound. So when you take the weight of the ice away, the land lifts up. It's like a sponge.
Really?
Yeah, it's recovering from the weight being removed from it. So the whole island is tilting. The northern part is rising because the ice has been taken away. So it's tilting at a very, very slow.
Jar of pizza, my friend. Yeah, tilting. So Amazon, working on Barnes and Noble. Often a lot of authors have their own site or even a landing page where you can buy the thing direct from you. Is that the case yet?
Not at the moment, Mark.
Okay. Because I encourage the personal signing. It's a hardcover. So nice. But anyway, I think it's this would be a nice gift if you've got an uncle or a dad who's a bit of a whiz kid. I'd loved science at school. I think they'd love this.
Yeah. A cousin of mine would like a copy for his grandson. So I've promised him a signed copy for his grandson.
There you go. Unbelievable. What's your biggest hope? We talked about that you want people to really get. Is there anything else before we close off, Norman, you'd like to share?
Yeah. We need more understanding of science in the world. We need the media specifically to put much more emphasis on science, real science. That's my dream. The man in the street, in my opinion, is not well informed when it comes to scientific subjects. We have a huge job to do in improving that.
Right. And so books like this can help profusely.
I hope so.
I hope so too, my friend Norman. Interesting to speak with. Norman Stewart, ladies and gentlemen. The book is called Freed. I mean, you can see that, can't you? Freed from the Iron Grip of Frost. And it is available, Amazon.com, and it's in Kindle. So, listen, I hope you sell 1 million of them. Good on you for all the hard work you've done, and it's been an absolute pleasure speaking with you.
Thank you very much, Mark. Pleasure for me too.
All right, my friend, that's good. What an interesting gentleman, huh? Tell you what. Brainy. How did you do at science at school? Tell me. Did you enjoy it? I hated algebra. That's the one that helps me. Algebra helps me profusely with radio and television and print and everything else. Never mind. I hope you enjoyed today's show. Got a ripper coming up a bit later dedicated to authors this site. The show is called Nothing Like a Good Book with yours truly. And it's all about discovering your book and promoting your book and selling your book. And it's not a scam. I don't charge the earth. And you can afford it because I give you a plethora of choices. Okay? And after a lot of talking with authors and over the years and speaking and so on, and me being involved in the film industry and other interests that I have in life, we go right through to where, some authors want a screenplay. And we do that for you. And with professionals, because I live in a place which used to be, it's the backyard of Hollywood, really. We've got cinematographers and we've got directors, great writers. Anyway, you can have a screenplay. It's yours. You can take it to Hollywood if you want, anywhere you want, or sit down with us and have a chat. You might be surprised that for a fraction of the cost Hollywood would cost you, we can make a film for you of your book for a low budget, okay? It's an indie film. And they've been doing very well, haven't they? But of course, they have $1 million budgets. No, we make good stuff for what it is, but you'd have a memoir of that. Okay, so I've got to go. Thank you again for joining the show, and I look forward to seeing you next time. Okay.